All right, here we go. This is Unit 2, Lesson 1. We're going to be talking about using properties of exponents. So just want you to, take a look at this, put this into your notes. See if, and then we got just a bunch of different examples here. Okay, and we'll talk about it. Let's crop it. So the product of a power is basically if you have the same base exponent, you can add your exponents together. We should be good there. So again, a to the mth power times a to the nth power means I just have to add my exponents. If I have a power raised to another power, like m and n here, then you end up multiplying them. You can split it up right here. Negative exponents, remember anytime your exponent is negative, you're going to move it down into the denominator because a negative exponent is actually getting smaller. So 7 to the negative 2 is really the same thing as 1/49th. It's getting smaller and smaller and smaller. Any exponent to the 0 power equals 1. And just like the product of powers rule, we have our quotient of powers rule, but instead of multiplying, we're dividing, which means instead of adding, we are subtracting. So good to get those kind of rules into our brains again. A few examples here before we talk about scientific notation is, all right, I'm looking at let's say negative 4 times 2 to the 5th squared. So really what this is saying is, hey, negative 4 times 2 to the 5th times negative 4 times 2 to the 5th. I could also take this exponent and apply it to both terms. So I might say, okay, this is like saying negative 4 squared times 2 to the 5th squared. Well, negative 4 squared is 16. And this is like saying 2 to the 5th power raised to the 2nd. That means I have to multiply because I have power to a power. So this would be like 2 square root 10. And 16 times 2 to the exponent of 10 is 16,384. So that was one example. Let's do one other kind of example real quick. 11 raised to the 5th power divided by 11 raised to the 8th power. And then this is all to an exponent of negative 1. So again, remember, if my exponent is negative, I take it down into the denominator. And so I should have 11 to the 5th over 11 to the 8th. But then when I divide fractions, I get keep, change, flip. So what I end up with is I flip-flopped my numerator and my denominator. So to get rid of this, I moved it all the way down here. But then because I had a fraction in my denominator, to move that fraction out, I multiplied by the reciprocal, and I ended up getting basically what I started with, but I flip-flopped my numerator and my denominator. So now I can simplify 11 to the 8th over 11 to the 5th. They have the same base, which means I subtract the exponents. So I get 11 to the 3rd, which equals 1,331. So oftentimes what we see exponents being used is through scientific notation. So scientific notation kind of works like this. You'll probably, if you're in chemistry, you've used it, maybe in physics, scientific notation. You're going to use the exponents. So really what you do is you take a number, and this number is between 0, whatever this number is, and we'll say it's less than 10. So it's greater than 0, less than 10. And then you're going to multiply it by a number, and you're going to write that oftentimes with the base 10. So we're going to multiply it by whatever number we want with an exponent. So let's do an example. Let's say, okay, we are studying some land and the amount of animals per land. So we're going to say that we're going to study locusts, and we might say, hey, we're going to take the number of locusts locus equals the locust per square kilometer. And then you're going to multiply that by the number of square kilometers. So if we think about it, okay, I have 85 million locusts per square mile or square kilometer. And I'm going to multiply that by the number of square kilometers, which I have being 1,200. So we're thinking, okay, how could I potentially write this differently? I need to get this number, this first number, into a unit of 10. So if I think about right now, this decimal point is all the way at the end. This is a multiplication sign. So let me clear that up. Okay, and then if we go 1, 2, 3, 4, no. 1, 2, 3, 4, 5, 6. If I moved it 7 places over, I could get a number that would be 8.5. So I'm going to call this 8.5 times 10 to the 7th power, because I need to move that decimal over 7 places. And then I'm going to rewrite this one as 1, 2. If I put a 3 there, then it gets rewritten as 1.2 times 10 to the 3rd. So again, taking this, multiplying it by this. Now we might be able to do something here. So I'm going to say, hey, I'm going to go ahead and I'm going to multiply these two numbers together. And then because these have the same exponent and the same base, I'm going to multiply those two. So 8.5 times 1.2 gives me 10.2. And 10 to the 7th times 10 to the 3rd is like saying 7 plus 3. So that's going to give me multiplied by 10 to the 10th power. And since we don't want a number bigger than 10, I'm going to move my decimal over one spot, which means if I move it over one spot, I got to add a multiple of 10. So I would say that this is 1.02 times 10 to the 11th power. All right. So that was kind of a review of scientific notation. A few more simplifying expressions examples, and then we will be good. So let's take b to the negative 4th multiplied by b to the 6th multiplied by b to the 7th. And so again, because they have the same base, I can go ahead and add my exponents. Negative 4 plus 6 is 2. 2 plus 7 is 9. So after simplifying, I get b to the 9th power. Could have r to the negative 2 over s to the 3rd. And then this whole thing is going to be raised to the negative 3rd power. So what I'm going to choose to do is I'm going to distribute this 3 into the top part and the bottom part of my numerator and my denominator. So this is r to the negative 2, still multiplied by negative 3. And this is s to the 3rd power multiplied by negative 3. Negative 2 times negative 3 is positive 6, which is nice. But then I get stuck with s 3 times negative 3 equals negative 9. And I don't like having negative numbers in my denominator. So again, to get rid of the negative number, I'm going to, if it's in my denominator, move it to the top. And if it's in my numerator, I'm going to move it to the denominator. So I'm going to bring this up and say r to the 6th, s to the positive 9th. R to the 6th, s to the positive 9th. Because when I move it from the denominator to the numerator, my number's getting smaller. All right. One last example. If we have 16 m to the 4th n to the negative 5th all over 2n to the negative 5th, I'm going to first, again, find things that are common. I see that I have 16 and 2, and then I see that I have n with exponents. I don't have an m, so I'm not really going to be able to do much with that. 16 divided by 2 is 8. M to the 4th stays on the top. And so when I have exponents that have the same base, it's like I am subtracting. So this is saying n to the negative 5th minus negative 5. Well, minus a negative really is like adding. And negative 5 plus 5 cancels out. So this is really like saying n to the 0 power. It's not n to the first power. But when we know that n to the 0 power, anything to the power of 0 is really like saying 1. So my final answer is just 8m to the 4th times 1. We don't need that. So again, this cancels out and becomes a 0.